Hi everyone, how are you doing? Are you enjoying KCD so far? Yeah. Fantastic. I hope lunch was not too heavy, otherwise we have the immutable lightness of the Edge platform. That joke, I was waiting to do that.
That was a nice joke.
Yeah. All right, so yeah, we want to talk about immutability and Edge platforms. And before that, I want to introduce myself. Hello everyone, my name is Mauro Morales. I am a staff engineer at Spectral Cloud. We do, and I'm very sorry if marketing is watching this video, we do manage Kubernetes pretty much everywhere. That includes at the edge. And we invest a lot in open source, hence why I'm a maintainer at Kairos, a fully open source project from CNCF. And I'm also a co-host at the Cloud Native Community Belgium. Now to the gentleman here.
Good afternoon, everyone. My name is William Rizzo, based in the Netherlands. I'm a strategy lead at Mirantis. I'm CNCF ambassador, Linkerd ambassador, contribute to open source, part of the release team at Kubernetes. And then that's it. So before we get started, I have one question for everyone. Does anyone know who Milan Kundera is? Milan Kundera? No? Okay. He never wrote any tech stuff. So he wrote a book that was called The Unbearable Lightness of Being. And that's the tension between lightness and weight. And lightness of thought, like freedom and all these things. And we're going to see how that applies to, how do we believe that that applies to immutable systems. One more question. Does anyone know these two sentences? Raise your hand if you do. Stefan? No? The name Fowler. Does it ring a bell? Now it does, huh? Okay. So the Phoenix server is something that is funny. I was at a talk before with Stefan Prodan, maintainer of Flux. He mentioned using Puppet to manage the state of systems, the configuration of systems. Anybody use Puppet? They're still alive, Stefan. Chef? Anybody use Chef? Also them are still alive, Stefan. So those systems are not bad, right? They're good. They manage the state of the configuration of a system. We have this concept of the Phoenix server, this rising from the ashes server, which was introduced by Chad Fowler in 2012. And in 2014, Martin Fowler, and in 2014, a blog post from Martin Fowler, 2013, still talking about immutable systems, how we should be able to rely on a state of the system that is not going to change. But we are 12 years behind this, 12 years after this, we're still talking about these problems, right? Chef and Puppet are great tools, were great tools. The problem was that they were looking at one aspect of the system. So that configuration was the state of the system. But an operating system or a server, it's much more than that, right? There are libraries, there are patches and packages that need to be applied. And there is mutability that takes care of this.
Indeed. So yeah, I don't know how many have seen that movie, Terminator 2. It's a bit famous. And they had this T-1000 robot that could morph into different shapes, right? And I think it shows as a very powerful mean tool, right? And I feel with mutability, we get this idea of power that we get with our systems. It's so easy to go and install a package. It's so easy to go and change a configuration, and it makes us feel good. I am in control of my system. But the reality is that that ability to do those changes is actually what brings many problems. What kind of problems, you might ask? Problems like drifting of configuration. Sure, you might have a configuration management system that is running and putting something in the right state, but that system can fail at any point, right? Leaving you with a system that didn't finish to the desired state. So in this way, you can find many of those problems. Back in 2015, I was working on a tool called machinery. You probably didn't hear of it. It was not particularly famous. I was very proud how we were doing it. It was, engineering-wise, I think it was very well done. What this tool used to do is that we would go and introspect Linux systems. We would go and check the exact way in which it was, which packages it had, which configurations it had, and how different they were from what the upstream maintainers were designing to do. And also you could do diffing, for example, between, okay, I inspect this system in the morning and I inspect it in the afternoon, and I could see the differences between these two systems. Very, in my opinion, elegant, it was nice, but the problem was that we should have already known how the system should have looked, and the system shouldn't have changed. There was no reason for the change to happen. And so the problems that come from this kind of really smart tools that we sometimes try to come up with is that, yeah, something happened with our server. Did someone introspect it at the right moment to know what happened? No, last introspection that was done was, I don't know, 15 minutes before the issue actually was introduced. Too bad, right? Like this doesn't bring the solution that we want.
And this is exactly what we just said, right? The tools that we had in 2010, in 2009 even, are looking at an aspect of the system, making sure that is according to what we want, but we're not looking at the entire system. We don't have anything that tells us the system has not changed. We don't need to change the systems. And the question is, do you actually need to change the system? I want to raise a hand. Who thinks that the system should mutate throughout the life of the system? You think that it should? Okay, good.
Always.
I have, let's go back a moment on that one. So, what I said before, Milan Kundera's tension was between lightness and weight. The lightness intended as freedom of thought, impermanent detachment from a state, and the weight being a responsibility, persistence, consequence, reliability. So if we go back and from an engineer perspective, this is a far-fetched, right? Kundera is a philosopher, and let's look at an engineer, which philosopher is closest to a physicist. I mean, but it's okay. So we want to deploy fast, we want to provision often, we want to make sure that we change the system often, as Stefan just said. Agreed? But we also want it to be secure, we want it to be reliable, we want it to be dependable. We want to know what is the state of the system when we are looking at the system and when we are not looking at the system. So these two things do not match. We want to change the system, but we want to also know the state of the system. So at the edge, let's bring it to the edge, this situation. So we have problems at the edge. What is the weight of, what we call the weight of the edge? We have systems that are disconnected or partially connected. We have systems that are exposed to security concerns, right? We want to make sure that the system is not compromisable if a bad actor is approaching the system. What type of system am I talking about? I might be talking about antennas, 5G's antenna, but I'm also might be talking about a system that is evaluating life as sort of a species of some sort of wolf that is endangered in the field, and that system is exposed to nature, but it's also exposed to a hiker walking by. It's like, hey, I want to grab this Raspberry Pi or whatever it is, right? So, or I want to boot this system in another operating system. So these are the problems that we're looking at. I want to make sure that that system is not bootable. If it's grabbed, if it's stolen, it's not usable. Can I do that? Is it possible to do something like this? Yes or no? Is it possible so far? It actually is possible, right? So when we are talking about changing a system, we might not be talking about actually changing it. What we are suggesting is replacing what the system is at time 0 and at time +1 or at time +2. We are not changing what is running, we are replacing what is running. We are not patching what is running, but we need to replace something to what is supposed to be running. And we have an opinion of how that can be achieved with the operating system at least. Let's see how we take it further. We already, by the way, if you are into hardware, like at least I am, can I get a gauge? Who is into hardware like me? I got you guys. Nice. When we are doing microcode upgrades, because the other people call these firmware upgrades, but we call it microcode upgrades. When we're doing microcode upgrades, we're never patching it or we're never actually upgrading it. We're always doing something that Mauro will show us on operating systems. We are actually replacing that microcode. We're always doing something called an AB upgrade. So,
nice.
Mauro.
Thanks, William. So yeah, today I want to talk a little bit about immutable OSs in general, but more specific from the perspective of Kairos. Part of it is this evolution that we've had from, through the DevOps lens, we were talking about going from pets to cattle, right? But at the end of the day, cattle is still, you know, like William likes to say, so sometimes those cows could also be pets, right? And let's face it, some teams sometimes treat some of their cattle like pets because, and why do you think this is the case? Why do they do it? Simply because they can. If you couldn't, then no reason to think like that. And that's why I like to promote the idea of, instead of thinking of it as cattle, let's think of it as appliances. And what would an appliance look like? Here I have 4 characteristics. We should not have any snowflakes anymore. When I talk about snowflakes, I mean you deploy a fleet of machines and one or many of them happen not to be exactly with the description that you intended it to have, right? It's a drift from the original configuration that you wanted to have in that machine. It must have AB or atomic upgrades, which is what William was just explaining. So in a way, I am upgrading the system, but in reality, I am replacing 100% the previous system with a new system. It must be able to do factory resets and recovery. So,
sorry, anybody ever heard of atomic upgrades? AB upgrades? Yes? Okay, cool.
You must be able to do factory resets. So let's say I want to repurpose a certain machine. I should not be able to do anything more complex than simply tell it to factory reset like we do with our phones, for example. Maybe our phones is one of the best examples for these 2 last points. AB upgrades, most of our phones have been doing a full switch into a new system for a while now. And factory reset the same. You just go say I want it as I received it from originally when I bought it, and that's exactly what you get. And it should be a declarative configuration, which is something that maybe we are already quite used to at this point. So which options do I have? This is not a final list. There is more out there, of course, but these are all operating systems that are running at the CNCF at the moment. It all started with CoreOS, which is now a Red Hat solution. But all of the big players have one option there. For example, AWS have BottleRocket there. Microsoft has Flatcar. SUSE has MicroOS. There are other smaller players. Today I want to talk to you about the best of all of them. Kairos, which of course I'm biased. What is Kairos? Kairos, we like to sell it as an immutable operating system, but it's a bit more than that. It actually takes an operating system that you already have and mutates it into, sorry, that's the word, I picked the worst word I could have picked, right? And it transforms it into an immutable system. Why is this a good thing? It is a good thing because you might be working with a certain customer that requires that you use a certain golden image because that has been vetted by their security team or something like that. Well, you can bring that image and convert it into a Kairos system. You can, if you have already licenses for Red Hat or SUSE, you can start from those systems. Or if you simply, the know-how of your team is Ubuntu, no problem, you start from Ubuntu. You need a smaller footprint, Arch. I don't know, different options that you can use and transform them into Kairos systems. So that's, I would say, on top of the 4 things that I mentioned before that one of these appliance systems should have, one thing that is very unique about us is that we run on multiple Linux distributions. Another thing that we try to do also as open is that we allow you to choose different Kubernetes distributions. Right now we support out-of-the-box K0s and K3s, but we have the community also opening other different distributions, and I mean, we're happy to get contributions for more than those that we have at the moment. It also has this ability of do peer-to-peer clustering. What does that mean? Let's say that you want to start a cluster, but you don't want to go into the itty-bitty details of which one should be the control plane and which one should be the workers. Well, the system will go through a peer-to-peer network, spin up some ledger mechanism and start deciding who gets to be what in this role. Why is this useful? Because then you just start spinning up new machines and your cluster can either grow or go down in the amount of workloads that you might need to have, right? It's 100% container-based. Many of these operating systems are. It supports trusted boot. What does that mean? Well, secure boot is not enough when you are at the edge. Someone might actually change the system that is running on top. What you want with these machines is that I provision it for one thing, and that one thing only is going to be running in my machine, which is the example that William was given before. With Trusted Boot, you can do this. Why? Because we measure everything. We measure not only the disk image that you're putting into that system, we measure the kernel, we measure the init.rd of the system. Everything will be validated through your TPM chip in your machine, for example. And finally, no vendor lock-in at all, 100% open source. It's a sandbox project from the CNCF. Now, since we're talking about immutability, I want to explain a little bit how the immutability works at Kairos. I think it works similarly at with most of those operating systems. Sorry. But this is how we do it. At the center, you have what we call strictly immutable. This is where the things that you really don't want to change in your system, those are mounted read-only. One example, var.lib. So that means that if for some reason you're doing a package installation, you can type the command, but the result will tell you, no, I'm sorry, I cannot write into this system, so I cannot add a package. That means that that base that is strictly immutable will not change at all. Then we have a different area that we call persistent. This is information that you want to have accessible across upgrades. Remember that an upgrade is not changing the system itself, but introducing a completely new system. So that means that those two systems must have access to certain areas of the disk. In this case, for example, your home directory. Whether I use the, what we call the A partition or the B partition, it doesn't matter which of the two I access, I might want to access my home directory. And finally, you have certain areas of the system that are completely writable. For example, the logs. If the system could not write the logs, it would be pretty useless, right? So you must be able to fully write in it. It's the process to convert to create an appliance with Kairos is very straightforward. You define your system in code, you build images, you build as many, it's cheap to build images, so you build as many as you want. In this case, every commit should be a new image, for example. And then you might need to load it into a system or not. Like if you are provisioning, you might need to load it. If you're upgrading, you might not, because you can use you can use the repository to do the upgrades. And finally, you just need to boot the appliance, and it's going to be running, just like when you boot an Alexa, when you boot any of these systems that are just ready to run. A little bit more on detail on how this is done. Like I was saying, you start with code, is Docker files and YAML, so our bread and butter when it comes to Kubernetes. Then Kairos comes and helps you initializing that into a container image. That container image which will have something special, which is that it will include the Linux kernel, hence why I have there the Tux sitting there. And then you might need, like I was saying, to bootstrap it into like an ISO or a USB, where we also help you to do that. This maps very well to what we call day zero operations, where you're designing your systems. Then for day one, we provision that system. You might have different ways. Again, it's not the same if you're provisioning something in the data center than if you're provisioning a Raspberry Pi, right? That will be more a bit on your side. But on our side, we're going to make sure that that system that you're booting, that you're provisioning, sorry, is completely following the immutability that we just talked about. And also, in case you need that degree of security, that you also have trusted boot in your machine. And finally, for the day two operations, so this is the part where the end user might not even want to care what you're running there. They just want to be able to reboot in case there is a problem. Well, we provide, like I said, the atomic upgrades, rollbacks. In case an upgrade didn't function correctly, it will just run the previous system that was running on the machine, and so that you can also do factory resets, basically.
Thank you, Mauro. So these are some projects that are in the CNCF or none that are supporting us with building immutable systems. We go from this side, we're from K0S, Kubernetes, lightweight, single binary, zero friction, blah, 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 blah. Fantastic. You should definitely use it if you are not. We have Kairos. Mauro just told us what it is. We have Cluster API. Now, Cluster API specifically does not help us with immutability. There is, to deploy bare metal systems, we have two projects that are well known. One is Metal Cube, and another one is, yes, thank you, Tinkerbell. Sorry, I don't know what happened there. Tinkerbell. The problem is that they're not helping us with immutability. The Metal Cube is based on cloud images. It's based on basically doing a DD of the image that has been built before and then configuring it using cloud init. Fantastic approach. Doesn't work with immutable systems because they need to be installed and they need to write the hardware, the chips, to create that immutable. I don't want that guy to come and steal my precious piece of equipment and install another operating system or modify the operating system. That, for me, is a problem. I've been working on a project that is called Beskar 7, and it's an immutable, a Cluster API immutable infrastructure provider, only the infrastructure. So there's no bootstrap provider, no control plane provider. For specifically immutable systems, to build immutable systems. How does it work? The idea, I built 3 controllers. One is a physical host controller which ties directly into the, sorry, I'm talking over the wrong slide. So the concept is strictly for immutability. So we are not talking about cloud images. I'm not interested in cloud images. As I said before, I'm only interested in immutable system that you can install. I'm supporting these operating systems that you're looking at. Kairos, Flatcar, Talos, and Leap Micro. Personally, I'm having more success with Kairos than the others, but that's just me. It supports 2 types of configuration. It can be baked-in configuration like Kairos can do natively, or it can be a remote configuration. What is a baked-in configuration? Meaning that the cloud config is baked into the ISO that can be deployed, and the system will start up, gets its configuration, write the TPM, do all the nice things that we need the system to do, or I can pass a remote HTTP endpoint and saying where the configuration is going to be, picked up. That's particularly interesting when we are building clusters that are multiple nodes, because we're always building clusters, also single nodes, right? Then the last problem, that is the problem that we have in the industry, is Redfish. Redfish is a REST API designed by, agreed upon on the DMTF, and all vendors, they're all subscribed to it, and no vendor is actually respecting it. They all do their own implementation of the DMTF Redfish, and nobody's writing the endpoint consistently, meaning that the endpoint can actually change after a microcode upgrade. So if before I was talking with and this has happened, and I'm saying it out loud, it was Dell. Before doing a firmware upgrade, I was talking with the virtual media, which is what we call as a CD, as a virtual CD. Now I'm talking with the HID, which is the light to signal the support engineer which server you are talking to. So this has actually happened. The architecture of Beskar is not so complex. There are three main controllers plus a state machine, which is not designed, is not drawn here. A physical controller, which is talking to the BMCs and making a one-to-one relation. Everybody knows what a BMC is? On the big servers is that little computer that you talk to manage the big server. That's what it is. So there is a one-to-one relationship. That one-to-one relation is also something that is hard to manage when we're talking about blade systems, because blade systems have one BMC and several systems behind that BMC. So for the moment, I'm keeping the thing simple. Then that physical host generates a relationship with the Beskar 7 machine, which is a relationship that is established when I want to build a node that will become a cluster participant, a member of the cluster. Before that is only a physical host, and I only care about the BMC system. When I'm building a cluster, I'm building the contract, the Cluster API contract, Beskar 7 cluster to copy cluster, and again, closing down the contract with Beskar 7 machine to the cluster machine. Just a fun thing, does anybody know what Beskar means? No? Yeah, you do? All right, this is the way? Cool. So Beskar is a very, very strong metal that is built in the planet of Mandalore, and the Mandalorian armor is built with Beskar. So, and 7 is just the original name of Kubernetes. This is all that we had. So that was a pray for me to look for help. So if you guys can write some Go code, just come around and help, because I'm failing a lot of places. So that was all that we had. I don't know if we have time for some questions.
All right, so we'll take a couple of questions if there are any. Just put your hand up. Anybody? Going once, twice.
I know that this talk was more focused on the image part of like immutable systems, but how do you, well, edge systems, let's say, I don't know, I'm monitoring, I don't know, animals in the wild with a Raspberry Pi at the edge, with a worker nodes on the Raspberry Pi. How do you deal with, well, edge networking and also security? Because 9 times out of 10 when we put an edge device randomly in the wild, it will probably be on a shared network. It will probably be behind carrier-grade NAT. And so it's a lot of constraints when we think about Kubernetes networking, and also the network rates as well.
Yep. So for the security part, it will depend, right? Like some devices are made for security, others are not, unfortunately. Our Raspberry Pi doesn't really come with a solution integrated in the board that will help you. For that, I would suggest more an x86 system that includes a TPM chip. And with that, you can do attestation so that if someone wants to use your device later, I mean, they will steal it. That part we cannot.
From a physical standpoint, there's not much point you can do.
Yeah, but at that point, it's a brick device. They cannot do absolutely anything with it. So at least, I mean, you will lose the device, but you know that it's not being repurposed for anything, and you know that a bad actor cannot come, change something in your kernel, and all of a sudden you're also sharing some of your data to them, for example. And the network will depend the degree of network that you have or don't have.
For the network at the moment, we are not specifically doing something. However, I argue the fact, do you trust any network at all?
Well, depends. If it's in the cloud in the VPC, I tend to
Trust it?
well, to a certain extent. And the thing is, there's a time where you have some trust on it, even if it's never 100%.
I have a different opinion about trust.
In an isolated, like LAN network between nodes that only Kubernetes has access to, I tend to be fine with it. If there is other actors on the same network, then I will start being worried.
Interesting. Okay, thank you.
All right, well, we are now a minute over, so we're going to call it there. Thanks everyone for coming to this session. You're obviously more than welcome to hound these guys out in the hallways if you have more questions. We will have another talk in here in about 9 minutes and in the room next door. So, yeah, hopefully see you soon.
Thank you.
Thank you.